This course is EXSC 328 EKG, and we'll have several resources on this. You'll have these modules that you can listen to on tape, and we'll have a couple of books that you'll want to use and look at during the talking of this. And one of them is the course pack, which is the large book, and this is has a lot of examples and information on EKG. And the small text, which is the author's Bing, has a lot of information too. So I think the best strategy would be to, as you listen to me talking and looking at the PowerPoint slides, to also have these two texts with you in reference, and I'll reference them as we talk through this too. The course will be divided into 4 modules. Each module has 2 parts, and for each module there will be an exam that will be taken. At the end of each module, which will be at the end of part 2, I'll go through a brief description or review of the exam for each section. These all of this material will be on Blackboard, and the speaking of this material will be in iTunes, and it'll be transcribed for you to read also. But again, if you can be referring to the PowerPoint slides and then the 2 books as I talk, I think that will be helpful. One little hint too would be to feel free to pause. So if I'm talking and we can look at an EKG together, you could pause it, read it yourself, and then get the answers from there. So we'll begin then with the first module, and the first part of the first module, and this is titled, and so I'm just following the PowerPoint slides, Electrocardiography or EKG Fundamentals. You can also say ECG. That would be equivalent to EKG. And as we look at this, I want to look at electrophysiology, which means kind of the how this works from a foundational aspect, and then eventually analyze one EKG beat, one heartbeat, and then look at a couple of different skills, including how to measure the heart rate for somebody based on an EKG, and also to measure the intervals that are involved on the EKG. But this is all stuff that we'll be learning in the next few minutes on this module. Again, Module 1, Part 1. So if you advance then to the next slide, the beginning point would be to think back to human physiology and even anatomy on the conduction system. And this is shown in the course pack. Again, the course pack's the large book on page 1, and so you can kind of follow the drawing of it that's in there, and then on this slide. So if you think back to physiology, you have the autonomic nervous system coming into the heart. The autonomic nervous system has 2 branches, the sympathetic branch and the parasympathetic branch. And remembering from physiology again, the sympathetic branch is making things go faster, usually during exercise or any kind of stressful situations. And this will give input to the SA node, which is shown on page 1 in the upper right portion of the right atrium. And this would generally accelerate the heart rate, make it go faster. The parasympathetic branch is slowing things down during resting time and sleeping, things of that nature. And again, this is giving information to the sinoatrial node, or often just called the SA node, to slow things down. In other words, give a slower heart rate. As the message travels from the SA node, which is usually the beginning point for the heart rate or heartbeat, and we'll talk about some exceptions to that in a little bit, but that's the main starting point. The information travels through the internodal tracts. You can see those shown on that page, down to the AV node, atrioventricular node, and then into the AV bundles, or bundle, singular, also called the bundle of His. This bifurcates into the right and left bundle branches, and the left bundle branch has fascicles that are called left anterior fascicle and left posterior fascicle, and all of this information then traveling through there, and again I know this is a review for you, ends up in the Purkinje fibers, which are located in the endocardial myocardium, And this is the connection point from this conduction system, which is specialized, almost like neurological tissue that is specialized for passing information, almost like a wire, if you're wiring into a light bulb, that type of thing. And then this is passed into the myocardium, which includes myocardial cells, and then therefore these cells pick up the message and the heart contracts. So you have an electrical message and then a heart contraction following the electrical message. The electrical message is the EKG. And so you'll see the different waves and information that are occurring, and from these waves on this electrical message we can determine all kinds of things about the EKG, including things like axis that you'll learn about, rotation, myocardial infarction, dysrhythmias, a lot of different things that are coming up throughout the course. So that's the a summary of the first slide. Moving forward, we want to talk about the cardiac cellular action potential. And to get to action potential, this is the next slide on here, number 2 in the outline, we're looking at the process of depolarization. Depolarization is where sodium ions are going into the cells of the conduction system, also the myocardial cells eventually, and potassium is exiting. And this creates an action potential or message that causes the EKG to form, the waves that we'll see, and then eventually the heart to beat, and again, it's an electrical message. These cells, after they have contracted, will have to reset, and this is called repolarization, and this reverses the whole process. So you have potassium coming into the cells, and then sodium is going back out during the repolarization process. And so it's a reverse, and everything is reset for another heartbeat. And again, this is occurring in the conduction system and then into the eventually the myocardial cells for contraction. So that's a summary of the next slide. As we go forward then to the next slide, we have the term vectors, number 3 in the outline. And we're looking at the main depolarization vector, which on the EKG is the R wave. And what this means then is you have this electrical message coming through and the heart contracting and the R wave is formed. And in fact, if you look on page 1 of the course back at the bottom, you'll see the tall upward pointed deflection is the R wave. And that's the main depolarization vector. Then the heart, we're talking about the repolarization, and the main repolarization vector on the EKG is the T wave. And this is a deflection that occurs after the R wave. It's a little more, usually a little less in amplitude. It's a little more rounded off, and most of the time it's upward, but there are situations where it can be downward too. The R wave is always deflected up. The T wave generally deflects upward, but can also have different positions on the EKG that we'll talk about as we go forward. So if you're looking on page 1, again at the bottom you can see the R wave and the T wave on there. We'll get back to the waves in a few minutes, but I want to kind of conclude this little section with the idea of this starting the heartbeat again, kind of going back to the first information. The SA node is generally the point that starts the heartbeat, and the SA node is an average of about 72. Now this can vary a lot person to person, and this is at rest, but that's generally the starting point. If the SA node doesn't work right, if it fails for some reason, and later in the course, not in this module, but later in the course we'll be talking about different backup systems to the SA node, and these occur in the atria, junctional area, and ventricles. And these we'll end up calling these escape rhythms, escape beats or rhythms, either one. And again, later we'll talk more about that. But if you do have these backup internal cardiac pacemakers, the title of this slide, you can have this in the atria at about 75 beats per minute, junctional area, which is right around the AV node, at around 40 to 60 beats per minute. And this is often called nodal backup instead of junctional, but the term nodal is really not quite accurate because the nodal region of the AV node really cannot initiate a beat. So I would say the preferred term is a junctional rhythm as a backup, and this is around 40 to 60. A ventricular backup rhythm is around 30 to 40 beats per minute. But again, this is just information early in the course, just to think about briefly, but we'll get back to it later in the course. But think right now, most of the time, almost all of the time, the SA node is the pacemaker of the heart. The internal pacemaker starts the heartbeat. So this, I would kind of, think about the atria, junctional area, and ventricular area a little bit later, but mainly be thinking about the SA node starting the beat. As we analyze then a normal EKG, to the next slide, number 5 on the outline, we want to analyze one beat. And this is where I talked a little bit about these waves, but you want to memorize, the different waves on the EKG. As a maximal possibility, the waves are P, Q, R, S, and T, and then sometimes U. Nothing before or after that. Those are all the waves on the EKG. And so if you look at those on page 1, you'll see where they are. And this is a kind of a depiction of, a potential setup on here. There is some variability. One thing to mention here is the R wave, again, is always deflects up. It can never deflect in a downward direction. The Q wave and S wave always deflect downward all the time. So QRS has its set deflection, upward for R wave, down Q and S waves. The P wave and T wave can do different things depending on the lead. We'll be talking about lead systems in a little bit, but often they deflect up. But there are exceptions where they can be flat or down, or even what's called biphasic, which means up and down. And you'll see a lot of that throughout the course. And again, that's for the P and the T wave. The U wave, which is there sometimes, and most of the time not there, there will be cases where you'll see that it's there, can also, again, deflect up or down. And a lot of times you don't see it, but we'll look back, and it's not even shown on page 1. It's a wave that would occur right after the T wave, and usually kind of small, and again, usually absent, but we'll get back to that when it's pertinent to the course. Mainly be thinking about the PQRST. Also, as you look on page 1, you can see that there are points where, like before the P wave, after the T wave, and even throughout the middle, you can see points where there is nothing going up or down, and these are flat sections on the EKG, and this is where, or this is referred to as the isoelectric line, so we'll use that terminology for that. The EKG paper, and I want to go kind of back and forth with these slides, let's click forward for a second, is in metric units. If you want to zoom in, you can see this even better, but it has these small boxes that are going left to right, up and down, and they are always, on the metric system, by convention, 1 millimeter, left to right, up and down, 1 millimeter, like that. And then you can see the thicker lines on there, if you're looking at this slide, and that's occurring every 5 millimeters, left to right and up and down. And so we think in terms of small boxes being the thinner lines, the small ones, or the large boxes, like that. So if we click back to the previous slide, you can see that a small box, which if you go left to right in time, the EKG is going left to right as it's coming out of the machine, is equal to 0.04 seconds, or 40 milliseconds. And you can do this, mathematically, or just memorize, that situation. But up and down, we don't refer to the seconds, but this is just the left to right situation. And just as an aside, if you blink your eye, that's about 300 milliseconds. So you can see that that would be a lot of small boxes. The EKG paper is coming out fairly quickly. A large box, the thick lines, and again left to right as the paper is moving out of the machine, is equal to 0.20 seconds, or 200 milliseconds. And again, you can memorize that, or you can mathematically, think in terms of a small box and a large box. Small box is, or a large box is 5 small boxes. So if you multiply 0.04 times 5, you get the 0.20, or easier math, if you multiply 40 times 5, you have the 200 milliseconds. So get used to the EKG paper and how it looks, and it's all standardized and conventional and never changes. And so you just want to think in terms of those units. And so I'll click forward then again to look at the EKG paper again. And you have that. Usually it's best if it's on this kind of a pink background with usually a black pen either marking on it or burning into it. And then you get that contrast from that. If we go forward to the next slide, I want to work on skill 1, which is a skill that you've used in courses in this curriculum where we are trying to determine heart rate. And you can do that by palpating, the pulse in different areas in the body, often at the wrist or radial pulse. And so you've probably had a lot of experience doing that. And we also can do that by the EKG. We can figure out the heart rate. So we'll go through that technique here. I've done some studies where we tried to look at the accuracy of heart rate taking. It's been an area of interest. And when we do those studies, our comparison is always to the main, standard EKG, what it's like on there, because that's a definite heart rate. So the first, this is a slide then that shows an EKG, and I've just written on this, and the writing is probably not perfect, but kind of bear with it. The first thing, if you look at upper left, if we look at the rate, we can do it if it's regular. We can measure the rate at regular intervals. And what I'm indicating is if you have a part of the EKG, generally the R wave. If you have an R wave occurring every large box, which is really fast, the rate then is 300. And you can see I've kind of written that in as every large box. If I'll get over to the right in a second with the math, but let's move kind of downward on this slide. If you have an R wave that's occurring every 2 large boxes, then this is a little slower, but it's still at a heart rate of 150. The top one was 300, real fast, 300 and then 150. If it's every 3 large boxes, again, this is the R wave, then the heart rate is 100, and so on. You can kind of follow what's there. So you should memorize for the course the idea of 300, 150, 100, 75, 60, 50, and 43. And again, this is how often the R wave is occurring as it hits the EKG. This is one way to get the rate, and again, it has to be regular. We'll do a little practice with this and some of the counting technique here in a few minutes. But the idea behind this is that if you take the number on the top one, number of small boxes in between R waves, so that would be 5. If it's a large box, it's 5 small boxes, and divide that into 1,500. 1,500 is a constant. You get the heart rate of 300. If you divide 10 in there, you get the heart rate of 150. And that's why this works, because it's all in metric units, and there's a standard EKG paper speed of 25 millimeters per second. The 25 millimeters per second, and I'm just kind of reading through the slide, times 60 seconds in a minute. We all know that, 60 seconds in a minute gives you the 1,500 millimeters per minute. It's coming out at 1,500 millimeters per minute, and that's why you have the constant of 1,500. So you can get the rate that way, and again, we'll practice that in a few minutes. The time intervals then, just as kind of a review of this, 25 millimeters equals 25 small boxes. That's 5 large boxes, and that's 1 second. And then 5 millimeters, again, left to right, 5 small boxes. Every millimeter is a small box. That's 1 large box, or thick lines, and that's 0.20 seconds, 200 milliseconds. And then 1 millimeter, which is 1 small box, which is a fifth of a large box, is 0.04 seconds, or 40 milliseconds. And this comes back to some of that material we already looked at. It's kind of a summary of that. Another way to get the rate, and again, we'll practice this material, is if you look at the electrocardiogram on the bottom of it, you have pink lines that are going up and down, or vertical. And what I've indicated here is there's some pink lines on the paper. If you go from one pink line to the next one, that's 3 seconds. And you could actually go back and add up all the boxes if you want, usually done by large boxes. If you go another pink line over, up and down, that's a 6-second period. What I've done on this slide is I've put in a kind of a black dot above those two pink vertical lines, and that's a 6-second period. You can count the number of beats in that 6-second period, and so I have indicated 1, 2, 3, 4, 5, 6 beats. Those are the blue up and down lines indicating heartbeats, or again R waves. And so if you have 6 beats in the 6-second period, then you would multiply that by 10, because 6 seconds times 10 would give you a minute. And then if you have that period of beats in there. So this technique, which again on this slide is shown on the bottom, is where you are, basically counting, again to review it, counting the beats in a 6-second period, and then you're multiplying by 10. If you took your pulse for 6 seconds, you would multiply by 10 to get the heart rate in beats per minute, or you could just take the number and add a 0 to the right of it. So in this example, then you have 6 beats in the 6-second period, and you could add the 0 to the right, so you'd have 60, or you could just take the 6 times 10, and that gives you 60, and that's another way to get the heart rate. If you had, another example not shown here, but if you had, say, 9 beats, 9 heartbeats, as counted by counting R waves within a 6-second period, then it would be 90. The rate would be 90. If you had 15 heartbeats, the rate would be 150. So that's another way to get the rate. We'll do that sometimes a little bit later in the course, but not really to emphasize it right now. But that's really a technique you can use for irregular heartbeats. This sometimes happens in things like atrial fibrillation that we'll study later. But generally just kind of put that aside for now, and we'll use that later in the course. You can also use that technique if the heart rate is regular. It works both ways. But the main emphasis right now is back to the top of the slide, where we want to count the small boxes in between and divide into 1,500, or just do our counting system by the 300, 150, 100, so on, like that. And we'll practice that in a few minutes. The other skill, and again we'll come back to some examples of this, but the other skill that goes along with the heart rate calculation is the calculation of intervals. And this is where you measure from one point on the EKG to another point, and you can follow this. I'm on the next slide now. So skill 2, calculation of intervals, and you can follow this on page 1 in the course pack, or the next slide has information on that too. And a lot of this is what we've been talking about already, but some of it's a little bit new. The normal PR interval should be 3 to 5 small boxes. You should also be able to get that in seconds and milliseconds, as shown on the slide. And that's where you memorize that conversion of small boxes to seconds by multiplying by 0.04. Or if you want to get into milliseconds, you multiply by 40. So remember the 0.04 and the 40 conversion that we have talked about. And so this is a normal interval. If you're outside of 3 to 5 small boxes, say shorter or longer, then there's an EKG problem that we'll learn about later. But for now, that's the normal interval. QRS complex interval is 1 to 2.5 or 3 small boxes. The upper limit is split. It can be 2.5 or 3, and then you got your conversion to the seconds and milliseconds. And the QT interval should be less than 10 small boxes, and then you got your conversion on that too. And there's a chart on page 4 in the text where, this is small text that you can look at, where it shows that with the QT interval as the rate, and you should just know the trend on this, not necessarily the exact ones, but as the rate gets faster, the QT interval should get shorter. As the rate gets slower, then it can be longer. And males and females have different QT interval normals too. So just what I would do is look at page 4 and just see the trends on there, and not memorize the exact numbers. But what you should memorize is that in general it should be less than 10 small boxes, and then the times on that too. We'll be talking later in the course about long QT intervals that can be problematical. So generally less than 10 small boxes on that. If you look at the next slide, then you can see where the PR interval is measured from the beginning of the P wave to the beginning of the QRS complex. The QRS complex could start with a Q wave, but sometimes the Q wave is absent. And if a Q wave is absent, you just go right to where the R wave starts. So it's whatever part of the QRS complex starts is what ends the PR interval, as shown on that slide. And then you can also see that on page 1 in the course pack too. The QRS complex interval goes from the beginning of the Q wave, and again, if the Q wave is not there, you go at the beginning of the R wave to the end of the S wave. And at the end of the S wave is where the EKG pen is bringing the S wave up to the to where it starts to go from more vertical to more horizontal on there. And we'll be talking about that point later as what's called the J point, but we'll get back to that later. So it's at the end of the S wave. The QT interval is at the beginning of the Q wave, or R wave if there's no Q wave, and then to the end of the T wave. So you want to be able to measure those, and look at that slide as being the basically memorize the starting and the stopping points for those 3 different intervals that are important as we look at skill 2. So that when you measure the intervals, then you'll also make a call on whether they're normal or abnormal based on being, in a lot of cases, too long or too short. So with that in mind then, let's do some practice. So if you look at the EKG, you can measure the rate and intervals. And with this course, one of the important things is to, if you click to the next slide, is to actually practice and get these skills down and be able to do them yourselves. And so I'm looking at the slide now that says practice of skills 1 and 2, and we want to use page 2 of the course pack for this and come up with the answers. And before you, if you can delay on looking at the answers or listening to this part of it, you can maybe try this on your own and then compare what you got as an answer to what I'm saying and what we have listed as the answers. So we're looking on page 2 in the course pack, and we're looking at a couple of rhythm strips on here, which would be, again, rhythm strips would be a single lead, and then we'll talk later in the course about 12 leads, but for this material we can use rhythm strips, and on your exam you'll have, for measuring the rate in intervals, you'll be looking at rhythm strips. On page 2, then the top one I want to look at first, and this is where we can start to measure the heart rate. If you look at the second beat over, that's pretty close to a thick line. You can start to count over to another thick line over 300, so it's not 300, 150, not 150, 100, not 100, and then to 75, not 75, but it's somewhere, the rate is somewhere between 75 and 100 as far as going by that technique. You could also take the number of small boxes, and this one's actually enlarged a little bit, but the small boxes are, consider those to be a millimeter, even though it's enlarged slightly. It's about 18, and you could divide that, small boxes, you could divide that into 1,500, and that would give you a rate of about 83. So you could, either answer is correct because 83 is the rate, but 83 is the rate between 75 and 100 for the rate. If you look at the intervals on the same EKG, you can see from the beginning of the P wave to the beginning of the QRS complex, there's no Q wave. Often the Q wave is not present. You got 4 boxes, small boxes. Again, this EKG is slightly enlarged, and then you can do the math to get the 0.16 seconds or 160 milliseconds. You can measure the QRS complex interval from the beginning of the R wave to the end of the S wave, where it comes going from a vertical to horizontal deflection, and that's about 2 small boxes, and you can convert with the math. And then the QT interval going from the beginning of the R wave, because there's no Q wave, to the end of the T wave, you have about 9 small boxes. And again, do the conversion on the math for that. So be sure that you're able to do these skills. On the bottom EKG, another practice example, you could look at maybe the third beat over would be good. If you start to count, then large boxes, and this one is not enlarged, not 300, not 150, not 100, not 75, not 60, not 50, but it's between 50 and 60. And so that would be an acceptable answer, to be between 50 and 60. You can also count the small boxes and divide into 1,500 and come up with a rate of 55, which would be between 50 and 60 also. And then the PR interval is, as measured by the technique we did before, is 5 small boxes, QRS 2 small boxes, and QT interval is 10 small boxes on that. And so that would be, and then you can convert to your mathematical conversion too. So these are examples that are generally fairly, like the top one at 4 small boxes, and 2 and 9 definitely within all the normal limits. And then the bottom one at 5 is for the PR interval is right at the upper limit but within normal. 2 is within normal, and then the 10 is right at the upper limit, or right at about the normal area too. And so you're looking at examples, again, the QT would be less than or equal to 10 small boxes. So you have that right at 10. And so these are normal examples of rate in intervals, and again, be able to come up with those calculations as those skills for this. Okay, moving forward then to another topic, which is number 8 on here, which is standardization. This is something where the EKG is standardized for mainly the amplitude of the EKG, and the machine does this, so you don't have to worry so much about it. But it's you can also use the terms sensitivity or calibration or gain for this, and they can be used synonymously with the word standardization. If you look at, we'll jump ahead in the course pack just because it's an EKG that shows this, to page 10 in there in the course pack. You can see to the, and we'll use the CKG for future stuff too, but you can see to the far right, right under the 10, these kind of a squared off box, and that's set at 10 millimeters up and down. That's the normal standardization, and that's what it looks like. It can be on the right side or the left side, or be found that way. And what it means is the patient is producing, if the patient produces 1 millivolt of electrical activity through their conduction system, you'll get a 10 millimeter deflection. It's just set that way, 10 small boxes up and down. And it's also called the height or amplitude. So if the person produces, say, less than that, say half a millivolt, then you'll get a deflection that's less than 10 millimeters. In that example, just a 5 millimeter deflection, like that. So the machine is kind of gauging how big the EKG is. And the standard, almost all the time, you're using 10 as your standardization. There are 2 other possibilities. You can actually set the machine at 1 millivolt equals 5, and this will make everything smaller. And so if somebody has big waves that go off the sheet, for example, you can make them smaller, but then you have to mathematically convert. You're just making it easier to read. Or you can, let's say you have real small EKG waves. You can actually set it to where 1 millivolt equals 20, and then you make the EKG bigger and easier to read. But then mathematically you have to convert too. Those are the other 2 possibilities, the only 2 other possibilities. I wouldn't get too concerned about that at this point. Just the main idea here is the standard normal standardization is 1 millivolt equals 10, and again, it's just setting up the machine to give you the right wave height from that. The next topic is lead systems, and this is where we have looked at a couple of rhythm strips, and we'll be talking throughout the course about rhythm strips, and that's what that means is just a single lead, just one strip on there. Page 2, if you go back in the course pack on that, those were examples of 2 rhythm strips. We'll be doing a lot of rhythm strip work throughout the course. But another way to look at the EKG that is very important and you should be aware of is what's called a 12-lead EKG. And there's, first of all, a standard 12-lead EKG where you take your patient, as shown here, and you look at the person or the person's heart from 12 different perspectives or 12 leads. And if you look at page 10 in the course pack, you can see that there are 12 different leads on here, and they're labeled. This is where we were before on page 10. Leads 1, 2, 3, AVR, AVL, AVF, V1 through V6. And they're labeled in their sections, and we'll be seeing a lot of 12 leads throughout the course. So get the idea of how to think in terms of looking at a 12 lead EKG. We'll have a lot of practice at this, but that's the standard setup. This course is a theory course where we look at how to do things, and then if you go into the sequence of our courses in our curriculum, where you go into exercise testing lab, you'll actually be able to do all this stuff and get the hands-on part of it. But one of the things you'll do in that, I've gone on to the next slide, is to look at the standard 12 lead. You have to place 10 electrodes. And the reason it's only 10 is that some of these electrodes can be used twice for different leads. And so you're placing these 10 electrodes on the body. And again, you don't have to do that for this course, but later in the curriculum, you would actually make that placement. These 10 electrodes go as indicated on this slide. Left and right arm on the wrists, left and right legs on the ankles. And you want to try to get it on soft tissue, not bone. And then you put your V1 through V6 onto the chest, onto the torso, based on what's shown on here. So you can, and again, you'll get the skill of doing that later in the curriculum. Maybe you palpate and you put V1 and V2, for example, in the fourth intercostal space, right and left sternal border, and then you actually place V4 next. This would be the fifth intercostal space at the left midclavicular line. The heart is tilting to the left, and then you actually have to place V3 after V2 and V4, and you put it on a straight line halfway between. And then V5 and V6 go in line or parallel to V4. So you just follow straight across the body. At the for V5, it's at the left anterior axillary line, and V6 is at the left mid axillary line. So you have these electrodes on the person. There's actually a picture of that on page 5 in the small book, and you can kind of see where they're placed. But again, just for this course, just know those definitions of where they are. And when you place the electrode, you end up connecting the lead wire to the electrode, and the lead wire ends up going into the machine. And to place the electrode, you also have to prep the skin. And if you need to shave, you would shave off the hair, and then you would clean it with some type of cleaning reagent, like, say, isopropyl alcohol, rubbing alcohol, and you kind of clean it off that way, and that gets the dirt and oil off there. And then if you can scrape it a little bit, you can actually scrape off the outer layer of the epidermis, which is called the stratum corneum, and you scrape that off, and then you put the electrode on, and that gives you a better connection if you do that. What we have in our lab is a material that actually does the cleaning and scraping at the same time, and does like after you shave, a single step on getting that prepared. And you put those, you can scrape an area of about the size of a dime, and then you put the electrode on over that cleaned up and scraped area for that placement. But again, that's a skill you would get later in the curriculum, and just know these definitions for this material. If we go forward then to the next slide, we were talking on the last slide about a standard 12 lead. And that standard 12 lead is where you put those electrodes on based on those definitions, and the person is lying down. If you want to have them exercise, now this is on to B in the outline, 9B, you can leave V1 through V6 the same. Just leave them on the chest. The problem would be if you leave the arms and legs on there and somebody, say, starts to run on the treadmill, they would pull off. So you got to move all of those electrodes that were on the wrists and the ankles up to the torso of the body based on these definitions. And you can read through those definitions, but that's one way to do it. That's method 1. And again, for this course, you want to kind of memorize that material as to where they end up being. There's another method where you can, if you go to the next slide, for, again, exercise. Again, you leave V1 through V6 the same. They can stay on the torso. And the arms actually the same as method 1. But in this method, method 2, which some labs use, other labs use method 1, bring the legs into these definitions that are on this slide. Left midclavicular line, lowest rib, right midclavicular line, lowest rib, like that. So you have a couple of different methods for putting on these exercise 12 leads. But again, this whole section is on 12 lead, And if we go back a couple slides just to review, you have the standard 12 lead, have the person lying down and place the electrodes there, 10 electrodes, and then push the button to take the EKG. If they're going to exercise, you can bring the electrodes, 4 of them, up to the body or the torso, and based on these 2 methods, and then you can have somebody cycling or running or walking, say on a treadmill, and you can be taking a 12 lead EKG on them too. If you move forward then to, still on lead systems, some of the bipolar leads. On the 12 lead, the bipolar leads are leads 1, 2, and 3. And if you look again at page 10, we're right on that in the course pack, you can see that to the far left their label is 1, 2, and 3. These are bipolar leads. And they have positive and negative poles to get their information. And these 3 leads then make up what's called Einthoven's triangle. You should be familiar with that name, Einthoven, from this point forward in the course. And this triangle is shown on page 6 in the small text at the upper left. And you can see that this triangle is, you could actually place this on the front of the body and figure out where leads 1, 2, and 3 are on the person. You can also bring these leads in, if you look from left to right on page 6 in the small text, you can move them in space to bring them into the next picture of them, which shows them at the same angles, but move to a different area. And then that also, if you look at below at the circle, you can see where leads 1, 2, and 3 are on the circle, and we'll be working quite a bit with that circle a little bit later in this module, actually in part 2 of this module, where we determine somebody's axis. That'll be coming up in a little bit. And but anyway, for now, those are the bipolar leads that are on the 12 lead, 1, 2, and 3. We'll look at other bipolar leads that are actually separate from a 12 lead. Those are the only 3 that are on the 12 lead. And then moving forward to the next slide, you also have unipolar leads. And the clue here is that anything with a V is a unipolar lead. So you have on the 12 lead, which could be a standard 12 lead or exercise 12 lead, AVR, AVL, AVF, V1 through V6. All those are unipolar leads. They take information over one spot or one pole. So if you place that on the body, they are getting information right there with one electrode. And again, the V means unipolar. These, the ones that are on the wrists, for example, would be kind of small because they're kind of far away from the heart, so they're augmented by the machine. Augmented means to make bigger, and that's why the A is in there for AVR, AVL, and AVF. And oftentimes in EKG, after you get used to this material, we just refer to those leads as R, L, and F. Take out the other part, but just assuming that's there. If you look on page 6 again in the text, you can see where AVR, AVL, and AVF are on the circle. And again, we'll be looking quite a bit at the circle later, a little bit later in the course when we look at axis. And so be thinking about that circle right now. So now we've defined the bipolar and unipolar leads. And if we look forward then to some more terminology, leads 1, 2, and 3, AVR, AVL, and AVF, are considered to be limb leads. And again, these are the ones we've been looking at so far on page 6 in the text. And they're all in the frontal plane. So if you take that circle, you take your book and flip it and put it against your chest, that circle, and this kind of goes back to anatomy and physiology, is on the over the heart in the front, in the frontal plane. And so you can, if you're lining that circle up over you, then, and I'm doing this right now with a book too, you put it over your chest, you should have lead 1, for example, where it's 0, should be on the left side of your body, like that. And then lead 1, where it goes to the other side of lead 1, where it says 180, should be to the right side of your body. Lead AVF, for example, should be where it says 90, where it's positive. At AVF, we'll be talking more about positive, negative in a few minutes. That should be toward the bottom part. So kind of down on your chest toward the bottom part of your heart. And then the other part of AVF at the top should be toward the top of your sternum, which is at -90. So that circle hopefully that helps in placing that circle over your chest, and that's considered to be the frontal plane. We'll be looking at that with axis here in a little bit. And then the other terminology is used for leads V1 through V6, V1, V2, V3, V4, V5, V6. These are in the precordial area, or precordial or chest leads, and they're in the horizontal plane. And this is where you would cut the body perpendicular from top to bottom, horizontal plane. And I'll review that a little more as we start to use that, because we'll be using those to determine rotation. The limb leads are used for axis, and the precordial leads are used for rotation. And I'll kind of come back to the exact position of those when we get to those topics here in a little bit. So for now, know the difference between limb leads and precordial leads. On the next slide, you have other leads that are off the 12 lead. And these are also called bipolar leads, bipolar transthoracic leads. These are separate from the 12 lead. If you work in, say, like a nursing area or a clinical care unit or a cardiac rehab unit, a lot of times you just put on 2 electrodes. And could be 3 electrodes because you might put a ground on there, but let's just say it's 2 electrodes. And you can put these electrodes on the body and you don't get a 12 lead, but you get a rhythm strip, EKG. So one of these is what's called CM5. And what this means is you put the negative electrode on the manubrium, which is the top of the sternum, and the positive electrode at the V5 position, which we defined earlier. So you get 2 electrodes on there, negative and positive, and that takes bipolar information on a single rhythm strip based on that position on there. And so the C in this case would be, it's a chest placement, and the M is manubrium. Another one is you could take the negative electrode and put it on the back of the person's physically on their back, near the right scapula. And you could then put the positive electrode again on V5. So you have the negative electrode on the right scapula and the positive electrode on V5, and you can take an EKG from that too. That's just another option. Another one is to put the negative electrode on the right, or just under the right clavicle. And then put your positive electrode again at V5 position and get a bipolar transthoracic lead from that too. Again, that just gives you a rhythm strip. Or you can take EKG paddles. And you can put the paddles, there are 2 of them, negative one somewhere up around the manubrium, the other one somewhere around V5, and that can give you a rhythm strip too, and that would be considered to be a bipolar lead too. So these are other options outside of the 12-lead EKG that can be used. And that ends the part 1 of Module 1. And again, that's kind of, or is, foundational information that has to do with kind of the beginning of this EKG course. We'll go forward now to continuing with Module 1 in Part 2.